Hello students, hope you guys are doing well. I am Abhishek Kumar. I am a BTech graduate from IIT Kharagpur. I have been associated with askIITians for last 4 years. In today's class, we will be dealing with fluid mechanics. Here we have divided fluid mechanics into two subsections. In the first subsection, we will be dealing with the fluids at rest, where we will be dealing with topics like buoyancy, Archimedes principle. In fluids in motion, we will be dealing with topics like Bernoulli's equation. Then we will be dealing with some properties of the fluids like viscosity and surface tension. So let's start the session. Hello students, welcome to the class. In today's class, we are going to deal with the topic fluid mechanics. Now in this fluid mechanics, we will be concerned with the Newton's laws and whatever else we have studied in mechanics, and will apply those to the fluids. Till now we have applied all the mechanics laws to the solids, where the solids were incompressible in the sense that they couldn't change their shapes. They were called solids. Now we are going to deal here with fluids. So before we understand how we can apply the fluid mechanics, the mechanical laws that we have to the fluids, we need to understand some of the basic terminologies, and then we will see how we can apply our same famous Newton's laws to the fluids. So we are going to deal with this in a series of steps. Now the topics that will be covered, first we will try to deal with the terminologies that we have for this chapter. Then we will see what happens to fluids at rest, means when the fluids are at rest, they are not in motion, what happens to the Newton's laws and how they manifest themselves in fluids. Then we will see what exactly is this Pascal's law, the famous Pascal's law. Then we will go ahead with the buoyancy and the Archimedes principle, the most revolutionary experiment and the guess that happened in the history of physics, and the famous Eureka that is associated with this Archimedes principle. We will see what exactly it says, although you may have some idea from your basic classes, but we will see into detail what exactly is Archimedes principle and how does it explain the buoyancy that we see in and around the objects in the fluid. Then we will move ahead. After covering all these fluids at rest part, we will move to fluid mechanics. Now in fluid mechanics, we will deal what happens when the fluids are in motion. Till now, this fluids at rest, Pascal's law deals with the fluids at rest, buoyancy and Archimedes principle, they are all concerned with the fluids at rest. Then we will move over to fluid dynamics. Here we will see how the fluids behave when they are in motion, how the Newton's law apply them, what is the difference from that when the fluids were at rest and now that it is in motion. Then we will move ahead to deal with some features of the liquid that are not so ideal, means the viscosity that we will see in detail, in further detail, that what exactly is this non-ideal behavior, what is an ideal fluid, all these things we will be discussing in the session. Then we will go ahead with surface tension. What exactly is this surface tension? This is also a non-ideal characteristic, we will see into this. And then we will move to excess pressure. What is excess pressure? Then capillarity. These are the topics in this sequence. We will be discussing all of the things, and then in the end we will be solving some questions, and we will be look into how now we can apply our concepts, whatever we have studied in our lecture here, to the questions being asked in JEE Advanced or JEE Mains or any other engineering examinations. So let us start with the first topic that goes to say terminologies. So let us see what these terminologies are that will be most frequently using in fluid mechanics. Now the first thing is, what are fluids? So now we know the matter is divided into three kinds that exist in the universe that we know, although there are two other kinds that we will not be discussing here. Now the most common we know is solid, and then is the liquid, and then there is gas. Now why I said there are actually 5 kinds of matter, these 2 kinds of matter that are called plasma, and then the another one that happens at the superconducting temperatures at a very low temperature and one at a very high temperature. Now these 2 states of matter, they don't occur in the nature on its own. Now solid, liquids and gases are the matters that you will find in the nature on its own. You will find that all of the matters, all of the things that are present in the universe are either solid or liquid or gas. You will not find this plasma and this semiconducting fluid at that temperature, which is more so kind of a bosonic system, That will be skipping, will not be dealing with those things here now, but will be dealing with these three. Now, what is a fluid? Now, a fluid is a substance that flows. It's a very basic definition. The fluid is any substance that flows. Now, from this definition, we can easily see that both the gases and the liquids are fluid, because the gases can flow as well as the liquids can flow. Now, then what is the differences between gases and liquids? If they are both fluids, what is the difference between them? Is it that all of the laws that we will study for gases are applicable to liquids, or if we study for liquids, are they applicable to gases? So we'll see what the differences is, but let's see what exactly this gas's structure is. So that will help us to explain the behaviors then. Now, gases are freely moving particles that you see. The distance between the two particles is very large. Means although you are seeing this, the molecule of the gas of very finite size as compared to this, actually it's almost negligible compared to the size of the container that you see here. In whatever it is contained, the size of the molecule is very small and it could be neglected. And the distance between any two is very large normally. Obviously they collide with each other, they collide with the walls, all these things happen, but normally the distance between any two molecules is very large. What happens in liquids? They are loosely bound particles. They are loosely bound in the sense that they have a space and hence they can flow. Since there is a finite space between these two which can change, this gives it the flow, and because of that flow it's a liquid. But then what's the difference? The difference is that it is compressible. You can compress the volume, you can make this volume like this and you will still have all of these molecules within this small volume. But what you will have is, since you have compressed it, the spaces between the molecules has decreased. But still you can compress it, you can change the shape. But changing the shape, changing the volume of the liquid is very difficult. We have changed the shape, we have changed the volume. But while we are dealing with the liquids, you can change shape. Shape can be changed. Volume is very difficult. Volume is difficult to change. It is very difficult to change the volume of the liquid, and that is why it is called incompressible. You cannot compress it. If you try to compress it, you will have to apply a very high pressure, and then you will have a very small change in the volume. Even if you apply very high pressure, you will have a very small change in the volume. That is the reason it is called incompressible. Okay. Now we will see in further detail what are these gases, how are they behaving. Now if you see here the gas molecules, these molecules are the gaseous molecules, they are moving freely through the space. You can see this is moving freely, this is moving freely, all of the gas molecules are freely. Now the molecules are far apart. As I have told you, although it appears to be a finite size, they are almost infinitesimal in size, very small, negligible compared to the volumes. So you can even consider them a point masses. Now this makes the gas compressible. Because there is a large space between them, you can compress that space. Because there is a large space, you can reduce that space. What happens in liquid, we saw, since there was a very small space, it was very difficult to compress that. So when you have the space, then only you can compress it. That's the reason it's compressible and the liquids are incompressible. Now gas molecules occasionally collide with each other. Occasionally they will collide with each other because these molecules are in constant random motion throughout. So they can collide with each other or they can collide with the walls. Like this is moving like this, it may collide with this or like this, it collides with the wall. So there is a whole kind of chaotic motion that's happening within. So this is a system in which the molecules through the spaces move as free particles. Again, this is an ideal characteristic, free particle in the sense, what do you mean when you say free particle? By free particle I mean that the motion of this is not influenced by any of the molecules that you see that are surrounding it. Now what happens practically? Practically what will happen, each molecule may be attracted or repulsed by the neighboring molecules, right? This molecule has electrons and protons, this may have electrons and protons. Suppose if they are charged molecules, then there can be repulsions, attractions like that. Even if they are not charged, there is some kind of polarization that is there. So there may be some kind of interaction, but we are neglecting all of those. You may have heard about van der Waals forces. Now van der Waals forces are the forces of interaction. We neglect even those forces. We neglect all such forces. So it's like a free molecule which is not influenced by any of the molecules that is moving. Only force that will act on this molecule is when it will collide with something. Then there will be a force of interaction. Otherwise there is no force. Now let's see what are liquids. Now a liquid has a well defined surface. We know if you put a liquid in a container, it will assume a particular shape like this. So it has a well defined shape. The molecules are as close together as they can get. The molecules are actually very close to each other. But now as you can see, since they can slide over each other, it is possible that they can slide over each other. This may come up, this may go down, this can move this side or this side. So there is a kind of motion that can happen. That gives it the flow. Now molecules have weak bonds between them. Now these molecules, they have actually the weak bonds between them. Since they are close, there is an interaction. There is interaction that is finite, that is measurable. That's why we don't neglect it here. We neglect it in the case of gases because the distances were very large. So we assume that the interaction that is happening due to the molecules is almost zero, because the distance is so large that kinds of forces, the van der Waals forces that I mentioned, the covalent forces, they are all almost negligible. But the molecules can slide around each other, allowing the liquid to flow and conform to the shape of its container. Now the reason liquid is called incompressible is because there is not much space between these two. So if you want to change the space, how you can do that? You can do it by compressing, but by compressing you cannot decrease the space between the liquids, which is already almost negligible. So they are incompressible. Now let's see what exactly is this mass density. Mass density, why I have written here mass density is because there are a large number of terms, a large number of things that will be referred to as density. Like there will be number density, the number of molecules per unit volume, there will be current density. All these things will be encountering while we go through our chapters in class 11th and 12th. So although most commonly we have used density, for mass density I have written it here as mass density. Means density is the mass with respect to volume. So we will see what exactly is it. It is the ratio of an object's or material's mass to its volume. So if an object, suppose this is an object, a cube like this, okay, it will have some mass. Suppose its mass is m. Now since this is a cube of side A, suppose its volume is a cube. This is a volume. So the density says density is mass by volume. Means the density of this will be m by a cube, if a cube is the volume. What is SI unit of density? SI unit of density will be kg per meter cube. Why? Because mass is kg, volume is meter cube. So the unit is kg per meter cube. Let's see a question based on this. Now a piece of glass is broken into two pieces of different sizes. How do their densities compare? Now if you see here, this is of the density, it has been given the name rho 1, this is rho 3, this is rho 2. Now it has been, this one has been broken into two pieces, 3 and 2. We have to compare the densities between these three. Now we know what exactly is density. Density is the mass per unit volume. Means the mass that is present in V volume. Now here if you see, the total mass will be m, okay, and its volume is suppose V. Now you break it into mass m1, the rest is m minus m1. If this volume is V1, this volume will be V minus V1. That is how these are broken into. Means if we assume it in this manner. Now we know density is the mass per unit volume. Means what is the mass that is present in 1 unit volume. If you see, suppose I make this space like this, this is 1 unit volume. What is the mass that will be present in this volume is called the density. Now if you, since this is a part of this, if you consider the same kind of volume here, it still has the same mass, right? Because it's a part of this. It's the part of this. So still if you consider any portion of it, a unit volume, if you consider of this, it will have the same mass as of this. So there is no change in the density if you break it. It is still made of the same material which had the same mass per unit volume earlier. So even when you break it, the volume has decreased, so has the mass, and still the mass per unit volume is same. So the correct answer is B. So in our session we have seen some of the terminologies like defining what exactly is the fluids, and we have seen the fluids consist both of liquids and gases, and then we dealt with density. In the next session we will be dealing with the topics like pressure.